Hello everyone, this is Dr. Roshan, and in this video I will be talking about why fasting hypoglycemia is seen in patients with classical galactosemia. So before directly jumping into the question, let me tell you the galactose metabolism in brief. Okay, so here we have galactose, and the first step of the galactose metabolism is the conversion of galactose to galactose 1 phosphate. Galactose 1 phosphate. Okay, and this particular step is catalyzed by the enzyme galactokinase. So galactokinase catalyzes the conversion of galactose to galactose 1 phosphate, and it is a type of phosphorylation reaction. So here the donor of phosphate is ATP, and during the reaction ATP is converted to ADP. So this is the first step of galactose metabolism, right? So in the second step, this galactose 1 phosphate is going to react with UDP glucose. Okay, so galactose 1 phosphate reacts with UDP glucose to form glucose 1 phosphate and UDP galactose. Okay, and remember, this particular step is catalyzed by the enzyme galactose 1 phosphate uridyl transferase. Uridyl transferase. Okay, so basically it is GALT, G-A-L-T, GALT. Okay, so the second step of galactose metabolism is the conversion of galactose 1 phosphate to glucose 1 phosphate, and this step is catalyzed by the enzyme galactose 1 phosphate uridyl transferase. Okay, so now this UDP galactose can be converted to UDP glucose. So actually this is a reversible reaction. Okay, so UDP galactose can be converted to UDP glucose, or UDP glucose can be converted to UDP galactose, right? And this particular step is catalyzed by the enzyme UDP galactose 4 epimerase. Okay, so see, UDP galactose can be synthesized from UDP glucose. So if you take glucose, then galactose can be synthesized from the glucose. This is the reason why galactose is not a dietary essential. Okay, now this glucose 1 phosphate is converted to glucose 6 phosphate. Okay, so glucose 1 phosphate is converted to glucose 6 phosphate, and this particular step is catalyzed by the enzyme phosphoglucomutase. Phosphoglucomutase. Okay, now the fate of glucose 6 phosphate depends on the need. If there is need of glucose, then glucose 6 phosphate can be converted to glucose in the liver, and if there is need of energy, then at that time glucose 6 phosphate can go into glycolysis in other tissues. Okay, so in liver, so basically in liver, glucose 6 phosphate is converted to glucose with the help of enzyme glucose 6 phosphatase. So here the name of the enzyme is glucose 6 phosphatase. Okay, so this is one of the enzymes of gluconeogenesis, right? And if there is need of energy, then at that time glucose 6 phosphate can go into glycolysis in other tissues. Okay, so this is how galactose is metabolized in our body. Now coming back to our question, that is why fasting hypoglycemia is seen in patients with classical galactosemia. So what is classical galactosemia? So remember, if this particular enzyme is not working, that is galactose 1-phosphate uridyl transferase is not working, then it leads to a clinical condition called classical galactosemia. Okay, galactosemia. So classical galactosemia is due to the deficiency of galactose 1-phosphate uridyl transferase. Okay, so if this enzyme is defective, then what will happen? So definitely there will be elevation of galactose 1-phosphate. So galactose 1-phosphate will be accumulated, right? So basically inorganic phosphate is trapped in the form of galactose 1-phosphate. So see, the first reaction is normal. Galactose is converted to galactose 1-phosphate, right? And in the first reaction you are consuming ATP. Okay, and here the defect lies in this second step. So in classical galactosemia, this particular enzyme galactose 1-phosphate uridyl transferase is not working. So galactose 1-phosphate cannot be converted to glucose 1-phosphate. So there will be accumulation of what? Galactose 1-phosphate. Okay, so basically, inorganic phosphate is trapped in the form of galactose 1-phosphate. Now the reactions that need inorganic phosphate will be interrupted. See, if you want to synthesize ATP from ADP, okay, so if you want to synthesize ATP from ADP, then definitely you need inorganic phosphate, and the name of the enzyme is ATP synthase. Okay, but here you have trapped inorganic phosphate in the form of galactose 1-phosphate. So there is down in the level of inorganic phosphate. So if there is down in the level of inorganic phosphate, then ATP will not be synthesized first. Okay, second thing is that, now recall the first step of glycogenolysis. So in the first step of glycogenolysis, so basically the first step of glycogenolysis is catalyzed by the enzyme glycogen phosphorylase, right? So glycogen phosphorylase catalyzes the first step of glycogenolysis, and what actually it does, it removes glucose from glycogen as glucose 1-phosphate, right? And this particular reaction needs inorganic phosphate. So here we need inorganic phosphate, but here in classical galactosemia the level of inorganic phosphate is down, so this reaction will be inhibited. So glycogen will not be broken down into glucose. So this is the very first step of glycogenolysis, that is glycogen is converted to glucose 1-phosphate, and later glucose 1-phosphate is converted to glucose 6-phosphate, and then glucose 6-phosphate into glucose in the liver, right? So the process of glycogenolysis will be inhibited, or you can say that this accumulated galactose 1-phosphate inhibits this glycogen phosphorylase enzyme. Okay, second reason is that, so there is down in the level of ATP here in case of classical galactosemia, right? And for the synthesis of glucose from pyruvate or lactate or alanine, we need ATP. So actually 6 ATPs are needed to synthesize glucose from pyruvate, alanine or lactate. But in classical galactosemia the level of ATP is down, so glucose will not be synthesized. Okay, and it will manifest as fasting hypoglycemia. Okay, thank you.